the facilities guys put the username and password on a sticky note stuck to the bottom of the monitor. Now, some of them get super sophisticated about this and they put it on the bottom of the keyboard.
Welcome, listeners, to the Industrial Security Podcast. My name is Nate Nelson. I'm here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions. He's going to introduce the subject and guest of our show today. Andrew, how are you?
I'm very well, thank you, Nate. Our guest today is Kyle Peters. He is a senior consultant at Intelligent Buildings, and he's going to be talking about safety and security and how it all fits together with IEC 62443 in building automation.
Then without further ado, here's you and Kyle.
Hello, Kyle, and welcome to the podcast. Before we get started, can I ask you to say a few sentences about yourself and about the good work that you're doing at Intelligent Buildings?
Yeah, thanks, Andrew. So my name's Kyle Peters. I'm a senior consultant for Intelligent Buildings, and I primarily focus on cybersecurity for building automation systems, which right now encompasses me doing on-site and virtual assessments of those systems, a lot of pre-construction document reviews, and policy and creation guidelines. And I kind of got started in this from the other side, where I was a programmer of building automation systems and moved over into this world, this side of things, by way of seeing problems that I was running into. And so now I get to help out the guys doing what I used to do to better secure their building automation systems.
Thanks for that. And our topic is everything from safety to 62443 in, cybersecurity for building automation. I understand that you do a lot of assessments in the space. Can you walk me through one of your assessments? What do you find in these buildings that you're looking at?
Yeah, so primarily we'll do, we like to follow the 62443 framework and the CSMS that you'll find at the end of part 2.1 of the standard. And that framework that walks us through, we get started on a project and we have a high level assessment. And so we do a lot more of those, of the high level assessments. And that's where we would walk into a site and visually inspect and do some very light work on the computer systems or investigation on the computer systems. And we're looking for vulnerabilities or threats or risks that exist within the building automation system. So I walk around and I might look at, I might find things like cellular modems that the vendor, the controls company themselves put in place for them to more easily do maintenance. I might find operating systems that are severely outdated. I might find network equipment that was installed in the early 1990s and is still running, hopefully, and probably covered in about 3 inches of dust bunnies. So it's those kinds of things that we look for, and that sets us up to move on down the line of the program so that we can get a more in-depth look and we can start developing policies and doing those sorts of things to really take their program and implement countermeasures and those kinds of things to make their program stronger.
Okay, and you mentioned 62443-2-1. I haven't read that in a while. You mentioned Appendix B. Can you give us just a bit of background? What is 2-1 and what's Appendix B and how do you use it?
Yeah, so 2-1 is, it's entitled The Establishment of an Industrial Automation and Control System Security Program. So it's basically just how you get started and how you get going with a security program within an industrial control space, or in our case, buildings. And Appendix B is the roadmap for that. And it literally has a diagram that shows where you're at. So we use that as our diagram for our whole program that we get going, and specifically as it relates to what we've been talking about with walkthroughs. That would be the second section, the high level risk assessment. And so that helps us determine what risks already exist within a facility, within a building automation system. And at that point, we're also going to start looking at what the target is that they're trying to achieve, so that we know where the disparities are and we can help the client develop their program from there into something that more closely reflects what they're trying to achieve.
So Nate, for anyone who hasn't looked at the 62443 series of standards in a while, I'm most familiar with 3-3, which is the one that says, you have to have antivirus here, you have to have long passwords there. IEC 62443 is the whole family of industrial automation standards. 1-1 is, concepts and terminology. It talks a lot about zones and conduits, which are basically, subnets. It's network segmentation. 2-1 is the one we're talking about here, which is getting started with an automation and control system security program. 2-3 is patch management. 2-4 has to do with, when you're establishing a program, what are the requirements for the program? So 2-1 is getting started. 2-4 is, all the rules. 3-3 is all the rules for, which controls to put in. 3-2 is doing risk assessments. 4-1 is secure product development. This is for the developers of products. 4-2 talks about requirements for security programs. There's a lot in there, and what we're talking about today mostly is the 2-1, which is getting started, designing one of these programs in the first place, as opposed to looking at individual measures like password length. So that makes sense, but you said a moment ago, when on your walkthrough, you're finding ancient gear, you're finding, dust and presumably neglect. It sounds a little depressing, when you compare what's there to what's in, 2-1. You find gaps, I assume. Is any of this changing? What's changing in this space?
So the biggest thing that has changed recently in the last 3 to 4 years, obviously with COVID and work from home, but it started before that, but that time frame really accentuated this, that remote access has become a big thing. And I think that is starting to drive more awareness towards cybersecurity for these buildings that before this, the most common thing we might hear is, what's the worst that can happen? It gets warm in an office, and now building owners and property managers are starting to see more of that risk because it's happening in other sectors, and they're realizing that they're online more now, so that risk is heightened at that point.
So remote access, I'm looking at the news just yesterday we're recording this here just yesterday. There was news that MGM had been breached. Details are scarce. Apparently the attackers claim that they did some social engineering. They made a 10-minute phone call to the help desk and got in. Now, they didn't say remote access, but my guess would be, I don't know, that someone gave them a password. Again, don't know how credible this is. It's very early days. Do you have a take on what's happening at MGM?
It as you mentioned, it's hard to say at this time, but I can envision bringing this over to the building automation side. If I were to call up and pretend to be the vendor, the programmer for their building automation system, maybe I installed their Tritium system or something. I don't have to have actually done it. I just have to know that it's there and pretend to be that guy and say, I'm really trying. They called. They've got an issue. I'm trying to help them remotely. can you go over, there should be a sticky note. This happens. I see this all the time. The building, the facilities guys put the username and password on a sticky note stuck to the bottom of the monitor. Now, some of them get super sophisticated about this and they put it on the bottom of the keyboard so that you have to turn the keyboard over to see it. But, if I called up, as you mentioned, if I call up a help desk and say, hey, I'm trying to fix this for them, can you just go look and tell me what that says real quick so that I can take care of that? That might be one thing. We can also, if I on a call, again, pretend to be a vendor and figure out what systems they have, then I know what protocols they have. And I might be a short Shodan search away from discovering where their systems are located at on the internet, finding an IP address and perhaps getting into things very quickly that way, just from a conversation.
The latest numbers in the 2023 threat report on OT cyber incidents show that the threat environment has changed fundamentally at the beginning of this decade. OT cyber attacks with physical consequences have changed, from a theoretical problem to a very real problem, more than doubling every year. The new report is focused on deliberate cyber attacks in the public record. These are attacks that cause physical consequences in process industries and discrete manufacturing. Most of these attacks are ransomware, though the fraction of hacktivist attacks is growing. And the report's appendix includes a complete list of all cyber attacks since Stuxnet that meet these criteria. To see how today's OT cyber threat environment has changed, I invite you to download the report, a joint effort between Waterfall Security and the ICS Strive OT Incident Repository. You can download the report at waterfall-security.com/2023-threat-report, or just go to the resources menu at the Waterfall Security site and click on white papers and ebooks.
So Nate, as you and I record, it's a few weeks after we recorded the session with Kyle. More is known about the MGM hack. The reports in public suggest that what happened was there was social engineering. The bad guys called up and persuaded the help desk that they were legit, and they had the account name. They'd done some research on social media on LinkedIn. They found some employee names. They came in impersonating one of the employees. Said, my account's messed up. Can you reset my two-factor authentication? So they had two-factor authentication allegedly. These are news reports, allegedly enabled, and so they called in and got all that reset so that they could log in and stole. I don't know. The reports I'm reading said unknown terabytes of information. So it was an information theft process. Allegedly, they were apparently eventually discovered. So they handed the credentials over to another part of the underground economy, the ransomware ecosystem, who started encrypting everything in sight and encrypted apparently a lot of servers and virtual machines, and eventually impaired the gaming systems, the access control systems, the reservation systems, and everything ground to a halt.
Yeah, I think that last bit has to be the most surprising part of this all for me, that you could, as a general ransomware actor that's just trying to lock up files and whatnot, end up affecting, slot machines and doors and such. How could it be that those systems are so interconnected?
Short answer is I don't know in this particular case. MGM hasn't published their network architecture. And I really don't know about the gaming machines. I don't know how that part of the industry works. But, let's talk about the door systems. When we talk about OT, I'm not sure I asked Kyle this, but, is the door lock system part of OT, or is OT really the air conditioning, the power systems, the sort of the hard OT? Waterfall puts out a threat report. Last year, there were 57 incidents worldwide that caused shutdowns of everything from buildings to, oil terminals. And very commonly, now I don't have the numbers, but it's very common that the ransomware group targets IT, does damage on IT, and then operations has to shut down because operations depends on something in IT. And, it might be that the door lock systems were in IT, or it might just be that the door lock systems depended on, I don't know, Active Directory to log into, and Active Directory was crippled. Or it might be that the door lock systems depended on some other system in IT that had been crippled. These dependencies seem to be responsible for a lot of physical shutdowns when it's IT systems that go down. But people haven't done the dependency analysis, and it bites them. Are people waking up to this?
I think so, yes. As we do more of these assessments, risk assessments that we've talked about, the eyes start opening a little more. And, here at Intelligent Buildings, we have a remote solution that's uses a zero trust architecture and whatnot. That's one solution. You guys, Waterfall, you have the unidirectional gateways, and I really do wish I saw a lot more of that kind of thing as well within building automation systems, not just in the industrial sector. So people are starting to take note. I'm seeing less and less unsecure TeamViewer connections, and more there. And there's other products out there too. There's more solutions coming up every day. So I'm starting to see more and more of that. But as much as I say I'm seeing more, there's still a long road to go. And as awareness grows, I think we're going to see that percentage of unsecure internet access or remote access sites, that number going down, hopefully.
When we were talking about the possibility of this podcast, I remember you used a buzzword that I wasn't familiar with. You said that, you do security assessments, risk assessments. You said you also do spec reviews. What's that?
Yeah, so a spec review, the specifications that come out leading up to a project. So before construction, be that a new construction, a building coming up out of the ground, or maybe we're redoing a floor. We get the specifications of what's going to be going in. So design documents and information about the systems that a vendor is planning on installing. So we look at those before they're built so that hopefully we can avoid building in issues from day one. There's all kinds of things that we see there, from specs that call out the use of ancient technology, outdated operating systems, those sorts of things. So we try to catch those issues when it's most cost effective to fix them, and that is before they are purchased. And then give those results back. The engineer reviews, they change the spec hopefully, and then we can help ensure that a building is designed and built to meet the client's own cybersecurity policies and their goals for being as cybersecure as possible.
I guess it makes sense when you're looking at a spec. You want to design the building to be sort of modern and secure. What does that mean, though? I mean, I'm guessing that a bank needs a different kind of system than does like a parking garage.
Yeah, absolutely. The risks are different, and we've seen all kinds of this stuff. I've seen it in doing assessments where the bank needs to protect against nation state attackers, that they're actually getting hit on a daily basis. And their parking garage may not have much more than fans and CO or NO2 sensors. And so they don't view the criticality the same. So they set different targets for that so that they can put resources where they have deemed that they're needed. So we use the 62443 standard to help get this program in line where they have their security levels of 0 through 4, where we say 0 is essentially we don't need to protect that system at all. And A 4 is the ability to protect against nation state attackers or something extremely high level like that. And most buildings fall somewhere in that 1 to 2 range where they need to be able to be resilient. They need, because the CO2 sensor, for instance, that's something that's critical in that space, but may not have quite the same impact if it goes down or is becomes vulnerable as the cooling system for the data center that keeps the whole bank running. So that's why they set different targets for different systems and different buildings, perhaps.
That's interesting. I mean, I'm coming from sort of the heavy industry perspective. In heavy industry, safety is always job one. If a hacker gets into the CO2 sensor and reprograms it to say, it's not 3% CO2 in the air that is going to trigger the fans, it's 90% CO2 in the air, that's a safety issue. People in the garage are going to get sick or worse. Should the CO2 sensor not be really thoroughly protected, just like the bank's data center?
It's a good point. And yes, it should be protected. We don't want that system to be completely vulnerable. I would never put that at a 0, for instance. But as far as the risk, maybe it's, depends on the construction of things, obviously. And so we still want to protect it, but do we need to put the amount of resources towards that that we do other systems? And that is up to the client, and that is up to what their risk tolerance is. As you mentioned, that starts getting into a life safety issue, which I think is important. So we would want to protect that. And maybe one of our protections is that we don't have connectivity to that system. Maybe it's a standalone system. I don't like necessarily having the air gap mentality as a firm way of protecting. So as someone might say, philosophy of protection for a system. But maybe we put that as read-only points. They have to be hard-coded in or something. So we find countermeasures that make sense for the application that we're looking at. This very issue is actually being discussed within a group called Building Cybersecurity.org. It's bcs.org. And we're working on taking the 62443 standard and making it more applicable to buildings and safety instrumentation systems that are very common within industrial controls are less common or not common at all within building automation. And so this is still something that is being debated on how to handle these things as this industry matures.
So Nathan, let me add here. I'm watching what some of the drafting teams are doing in 62443. Not just I'm not part of the building automation bcs.org. The question of security levels is being debated even more widely than bcs.org. What are security levels? Let me back up a moment. They're basically 4 levels that describe the capability of an adversary that you have to defeat with your security program. So, SL1 says, I've got a program that's strong enough to defeat script kiddies who know almost nothing, but, download a tool, press some buttons and get in trouble. SL2, in my recollection, is something like, insiders who've got some knowledge, who've got some permissions. SL3 is basically, they don't use the terminology, but I read it as organized crime. And SL4 I read as nation states. And so if you say I need, my network has to withstand an SL4 attack, it has to withstand a really sophisticated kind of attack. And safety systems, you might ask, well, how should they be protected? Well, A, that's being debated, and B, one of the observations I make in the book that I just released is that it makes sense. It often makes sense to use different security levels for different adversaries. And so if the ransomware groups nowadays are using what used to be nation state techniques and, they're trailing nation states by only a few years, it really makes sense to take really sensitive systems like these safety systems and protect them from nation state grade network attacks. But the other controls like the antivirus and, those controls really, or passwords or, access management, those controls really are relevant to physical access to people who are insiders, not who are coming in across the network. And the insiders tend to be much less capable. They tend not to be, to have nation state attack tool capabilities and knowledge. And so, what I'm seeing people start to do is using different security levels within the same network for different types of security controls. The controls that are focused on insiders might be set at an SL2, even for the safety systems, because the insiders just aren't that clever, bluntly. Whereas the security tools that are focused against network attacks coming in from the outside are at a much higher level. So yeah, it's something that's being debated in multiple places in the industry. This whole question of I call it the question of how much is enough.
I'm going to use it as an excuse that your book is very new, and so I haven't got a chance to read it yet. But I guess what I'm wondering is why you wouldn't otherwise just ramp up all of your defenses as much as you're able to. Is it just a matter of resources? Because in my head, when you say, okay, an insider doesn't have a nation state's capabilities, well, what if a nation state plants somebody in a manufacturing or wherever you're talking about? I know that that's a bit far off, but why wouldn't you overestimate their capabilities rather than try to guess exactly who you might be up against?
Well, you certainly, in theory, you can protect everything to nation state level, but it gets very expensive. And the question is it really needed? So, for example, if you have, if you're running something insane like a nuclear generator, you have to have everything at the nation state level, meaning even the security controls that you have deployed to protect against insider attacks, you've got to consider the fact that a nation state might put a sleeper or three, a spy into your organization 20 years ago and activate the spy today because conflicts are ramping up. Is it really reasonable for a building, an office tower with a parking garage to take measures that are sufficient to detect sleepers that other nations have put into their organization, 20 years ago? That's just overkill. So yeah, it's a cost thing. You look at the obligation that all of us have who are operating, dangerous equipment. The obligation we have is not to do the most that is possible. The obligation we have is to do something reasonable, to do what any reasonable person would do if they were in our shoes. And saying, I'm going to protect against, intelligence agencies planting sleepers in my building that, keeps, keeps a retail store going. That's just not reasonable. And it's a lot of money to spend on stuff that isn't reasonable.
I take your point, Andrew, and I agree. If you're operating a nuclear facility versus a building automation system, then you would apply different security controls to those two situations. But if I understood correctly what you were saying originally, it was that you would apply different grades of security to different kinds of systems within one site, which is what I'm more curious about. Like whether it's building automation or a nuclear facility, why you wouldn't set all of your security controls to a level 4 or level 2 or what have you.
That's a good question. So, I answered the question that certain security tools protect you against insiders versus outsiders, and outsiders nowadays tend to be much more sophisticated than insiders. So there's some distinction that you make across different kinds of tools within the same network. But you're asking, is the whole network, fine, you decide that it's SL2 for insiders and SL4 for outsiders, but is the whole network 2 for insiders and 4 for outsiders? Or, is it 3 somewhere? And the answer is that in theory, What 62443 says is, every little network that has a slightly different function, you might give a different security level to. In practice, that gets really complicated, and you start making mistakes about applying, the wrong security controls to the wrong networks, the wrong level of security control. So in practice, what I observe people doing, is applying pretty much the same set of standards, the same approach to security controls to entire networks, just because breaking stuff up into 73 subnetworks, each with a different security policy, is just hard. But in theory, you could do that. There you go. So that's progress industry-wide. This has been great, Kyle. Thank you for joining us. Before we let you go, can you sum up what should we be taking away here?
Yeah, I think the biggest thing to take away is that there is hope. That things are looking up, and the building automation industry is kind of slowly but steadily working on catching up to the IT industry and the ICS industries with regards to maturity in cybersecurity. As I mentioned, groups like bcs.org are doing great things to help push things along. And my advice would be that, if we're going to do things like remote connectivity and remote management of systems, don't be the bottom rung on the ladder. Let's start taking a look at this and take cybersecurity seriously. And it's not just who would want to attack. It's how do we keep our systems running no matter what happens? Somebody spills coffee on the server, those kinds of things are little things that we look at to keep systems resilient. And, here at Intelligent Buildings, like I said, we do the assessments, we do managed services to help keep things going once they're operational. So things like that, I think we're moving in a positive direction, and I'm very excited to see where the future takes us in this industry, and I love it. It's just a great industry to be in, with some awesome people of keeping buildings running for the world to keep working.
Andrew, that was your interview with Kyle. Do you have anything to take us all out with today?
Yeah, we've had a couple of episodes on building automation before. I'm reminded one of them, I think, has in the title 20,000 CPUs, and we talked about really how many CPUs in thermostats are scattered through a large building like a skyscraper, and how exposed these systems are, because people can touch the thermostats. They can pull them off the wall to get access to the wiring. They're exposed to attacks in ways that other systems just aren't. I remember an episode talking about destroying a 300-ton chiller by operating it too fast for a number of hours. The blades that moved the liquid coolant were moving too fast, and there was vacuum cavities forming behind these blades. Tremendous vibration over a course of hours that you destroy the cooler. And today we're talking about, BCS.org. The organization is debating security levels. It's basically asking the question, how much is enough? How much security is enough for different kinds of networks? And, I observe that I see that debate in the larger IEC 62443 standards community as well. And, the larger community, in part, there's many reasons to revisit this question, but in part it's because the threat environment's evolving. Tools and techniques that 15, 13 years ago, when the standard I'm most familiar with, the 3-3 standard, when that standard came out, the tools and techniques that nation states were using, that was SL4, today are being used by ransomware, which is SL3 adversaries. And so, how many of the security approaches, the security controls that used to be appropriate to nation states at the SL4 level now need to be reclassified at the SL3 level. All of this is being debated because, again, threats continue to evolve. And, I sum the whole thing up as with the question, how much is enough? How much security is enough? How high do we put the bar? This is, in a sense, a constant debate. But in the standards community, it's being specifically debated in the last, I think, 12 months or so.
Well, then thank you to Kyle Peters for bringing all of that to our attention. And Andrew, thank you for speaking with me as always.
It's always a pleasure. Thank you, Nate.
This has been the Industrial Security Podcast from Waterfall. Thanks to everybody out there listening.